Hello everyone, I will be explaining about the constant volume combustion chamber which is used for the gasoline direct injection spray studies, experimental studies. So this is the constant volume combustion chamber made up of the mild steel. It comprising 4 optical axes. These optical axes facilitate to get the view of the inside the combustion chamber. This constant volume combustion chamber helps in mimicking the actual engine like environment. It does not contain any kind of piston, so there is no movement of the air. There are various accessories which are mounted on top of this constant volume combustion chamber. This is the centrally located GDI injector. This is the position for the GDI injector. These are the line for the gas inflow and the gas outflow. These gases are the inflow gases are used to pressurize the constant volume combustion chamber, and once we have the vapor accumulated inside the combustion chamber, so through the exhaust line these gases can be taken out. The fuel are being pressurized through this line. The fuel is being pressurized through this line, which is connected to a high pressure pump. This is the GDI unit, gasoline direct injection unit. This comprising a high pressure pump and a low pressure pump connected together. So the low pressure pump delivers the fuel at around 4 to 5 bar of the pressure to the high pressure pump. It's a GDI pump. This is the GDI pump. So the GDI pump is being run with the help of this 5 horsepower motor. This 5 horsepower motor used to run the shaft, which used to actuate the cam and follower. This cam and follower connected with this GDI pump, which used to push the spring and the plunger that generates the pressure. This fuel is get pressurized within the common rail, which is then controlled through this valve. So we can increase or decrease the pressure in this fuel line according to our requirement. Then this is the electronic control unit. It's an open ECU. It contains an open ECU. The purpose of the open ECU is to control the injection events and monitor the different parameters of the flow, like the pressure inside the chamber, the pressure inside the fuel line, injection duration and injection events that are being captured. It is connected to this constant volume combustion chamber. There are different sensors which are installed, like the pressure sensor, the temperature sensor. So all these things this is the temperature sensor, K-type thermocouple. A pressure sensor is also mounted through this line, which used to sense the pressure inside this constant volume combustion chamber. This digital pressure sensor used to measure both positive pressure and the negative pressure. However, this pressure gauge used to measure the the positive pressure only. This is the fuel tank, and we have 2 lines, the outlet line and the inlet line, or the backflow line. This entire system is being operated from first through the main switch, and this ECU has been operated through this switch. We can also heat up the fuel. Inline heating of the fuel is possible with this system, with this existing system. This is the control panel for the constant volume combustion chamber. The constant volume combustion chamber comprises 4 heating rods that used to heat up the gas which is inside the constant volume combustion chamber. This is the main switch to turn on the heating filament. The heating filament is connected to a thermocouple, and it is based on the feedback signal. So whatever temperature you are set, the feedback signal provides the feedback, and in the loop it used to calculate what is the current temperature, and on the basis of that it turn on and off periodically based on the temperature which is getting maintained. There is also a provision to lift up the constant volume combustion chamber, so we can adjust the height of the constant volume combustion chamber. We can raise the height or lower the height depending on the requirement while we are performing the experiment. This is line. This one is the nitrogen line, which is connected through the common line provided by the institute. This nitrogen line is controlled by these valves. This valve used to allow and block the flow of the nitrogen into the constant volume combustion chamber. Using this nitrogen line, we can pressurize the constant volume combustion chamber to any given pressure, 4 bar, 5 bar, 6 bar. That is similar to that of the actual pressure inside the engine. These are the valves which are provided to control the flow of the gases. This valve is the intake valve. This goes inside the constant volume combustion chamber, and if we have to flush the gases within the combustion chamber, we have to open this valve. This valve is connected through another pipe. This pipe then goes to the exhaust pipe. In case if we have to remove the gases and create a vacuum inside the constant volume combustion chamber, the constant volume combustion chamber, this pipe, the exhaust line is connected to a vacuum pump. Once we turn on the vacuum pump and close the other valves, all the gases getting flushed out, and we have created a vacuum that mimics the suction stroke. At the time of the suction stroke, the pressure. The injector is connected to the ECU. This is the line which is connected to the ECU. The main line used to control the injection duration and the different injection event at the time once we used to operate with the characterize with the laser. This is the laser, NDR laser. So the wavelength of this laser is 532 nanometer and the power of this laser is 200 millijoule. It's a 4 nanosecond pulse duration and low speed laser. The laser is mounted on the breadboard table. The purpose of the breadboard table is to locate the laser as well as the other optical accessories. So these are the grids provided on the breadboard table. With the help of these grids, we can precisely locate the equipment and we can align according to our requirement at the time of the experimental characterization. The breadboard table are inflated with the help of these pneumatic legs. The pneumatic legs are filled with the compressed air. The air is then compressed with the help of this pump. The laser, this is the exit of the laser. The laser beam is of around 4 to 5 mm of size of the laser beam is coming out from this line. Then it goes through this diffuser optics. With the help of the fiber cable, the light travels and then getting expanded through this expander unit. The diffuse light getting expanded through this unit. The diffuser optics is placed along the line of sight of the constant volume combustion chamber, and on the opposite side of this constant volume combustion chamber, the camera is mounted. This is the Phantom VEO 410 high speed camera. The camera is mounted on a lab jack so that we can fix the location of the camera. At the time of performing the experiment, we have to always ensure that the frames remains fixed throughout all the operating condition. Otherwise, there are variation in the frame to frame at the time of post processing. This will create a problem. So the camera, the constant volume combustion chamber and the beam expander are placed in a line. So we have a line of sight. We have a spray imaging along the line of sight. Once the spray is getting developed inside this constant volume combustion chamber, it blocks certain part of the light which is coming from the diffuser optics. That will be then observed with the help of the camera. This is the software, Davis software, which used to control the laser and the camera and synchronize it with the spray event. This is currently, as we can see in the image, is the spray which is getting developed This green color portion is the light which is being produced from the diffuser optics. From this side, the camera is used to observe this light, and the spray blocks certain part of the light. This region is our interest. At the time of post-processing, we have to extract these details, and we have to further characterize some of the aspect like the penetration length, how far the spray is being developed from the tip of the injector and along the tip of the injector, the cone angle, what is the extent of the radial extent of this spray for a given instant. Now we can come to the different parameters, like what are the controlling parameters here. So we have the different options given here, like the exposure time, the intensity of the laser. All these things are important. If we increase the intensity of the laser, sometimes it oversaturates the images. The camera exposure time is very important. In order to freeze the movement of the spray, we always have to keep the lower exposure time. Then the single frame mode. At the time of performing the PIV experiment, we have to go to the double frame mode or dual frame mode. Then these are the cycle rates, and currently it is in the internal triggering, and the cycle trigger is external triggering. Right. This is the laser control unit, Litron laser control unit. With the help of this laser control unit, we can control the intensity of the laser light, and it also used to monitor the temperature, the water temperature, the deionized water temperature of the laser, the temperature of the laser filament. This is the chiller unit. This chiller unit contains the deionized water. The water is being circulated to keep the laser filament cool under certain temperature condition. This is the pipeline. We have to periodically replace the deionized water. Around 3 months we have to replace the water of the laser. Then these are some wires which is coming from this laser, the chiller unit. For the external triggering, these wires are connected to the system, and at the time of performing the experiment, we have to keep it as the external trigger. This is the data acquisition system. So this currently gives the exact temperature, pressure of the constant volume combustion chamber and the fuel line. So here we are giving the time duration for the spray, like 1500 microsecond or 1.5 millisecond. All these things can be changed from this given input, from this input. So this used to change the instants, the spray instant, at what instant we have to capture. We want to capture the spray, like 1500 microsecond after start of injection, and at what instant we have to perform the combustion. The spray images obtained from the laser based diagnostic technique, then further post process using the MATLAB script. So in the spray images, we have to extract these details, like the boundary of the spray, how far it is being developed, what is the extent, the width and the cone angle of the spray, and then we have to post process and at what time this spray has been captured. Like in this case, it was captured 0.65 millisecond after the start of injection, which is given as the ASOI. So similarly, we have the different instant for we used to repeat the experiment at a given instant to ensure the repeatability of the experiment. Finally, while performing the experiment, laser based experiment, we have to ensure that we always wear the laser safety goggles, which is specifically meant for a given wavelength and the energy output for a laser. These are very helpful, these are very essential to protect our eyes as well as the skin. We always have to ensure that we have to perform the laser based experiment, and we should not keep directly looking towards the laser beam or the light or the reflected light. as well as we always have to avoid the exposure of our skin to the laser.